we've now, let's say, evaluated, oh, I have machines that don't meet this requirement. I should go ahead and buy some equipment to make this better. So now we're going to dive into a specific customer story. So, and this kind of started my passionate journey down this road. So I have a customer that's an aerospace parts manufacturer, and they have grinders at every CNC operator station, and they use them for tool sharpening. And I was surprised that they're still probably using like high-speed steel instead of carbide for those, but whatever, right? So they have about 70 stations, so they have about 70 grinders. These are little guys, little like half-horse, three-quarter-horse grinders. And they realized that they needed some anti-restart protection. So they did everything reasonably. They Googled it, they went, they found something that looked like it would work, they bought it, they installed them, and it was great. Now they did something that really helped them here. So they, as part of their policy, regularly test all safety equipment. So think about that. That is something that you could very easily argue as part of regulation, right? You should always evaluate your the performance of your safety equipment after mitigation, and then at some regular interval, anything from a monthly test to a every shift test, depending on the mitigation. But they did this monthly, and what they found is that for their 70 brand new anti-restart devices, every single month between 1 and 3 would fail. So just to kind of visualize that, what that looks like, I'm gonna do a little animation on the screen. So every month, the restart prevention was failing, the brand new ones, on all these machines. Now, one of the things about, this is true for most restart products, is they fail silently. They can combust and kind of fail gloriously, but often they will fail without any kind of alarm. You won't even know. And so this customer was smart enough that they're testing them regularly, and so they found this. And this blew my mind. It's like, how could something be on the market that has a fail rate that a year after it's installed, this many devices are now hazardous again? That blew my mind. And so I started digging into it, and like any good engineer, I took one apart. And so you'll see, I try to specifically not call out any manufacturers here, because I want you guys to be able to do your own kind of informed research, and I don't just want to go down that road. But know that if you can recognize it, this is one of many, this is not the only one. So when we're going through and taking this apart, one of the things that surprised me was it had a very small relay in it, right? And the relay is this little black box, and this little black box is the main switching component, right? And if you're sizing something for switching a motor, and you have some electrical familiarity, there might be a few things you look for. One might be, is this switching device approved by a nationally recognized test lab? And in this particular case, the device itself is listed by UL, and the switching device inside it is listed by UL, CSA, and TUV, right? Okay, so it is a listed product, which means that it has been reviewed for electrical and fire safety by a nationally recognized test lab. Next thing you might say, is it have the correct voltage rating? And I'm using this example of a little grinder over here, right? So this particular relay, we're reading the top of it, it's rated for 125 volts. Oh, look, our grinder is 125 volts. That should work, right? Seems fine. And we see, oh, our grinder only uses 8 amps. Oh, this thing's rated for 15 amps. We should have plenty of margin, right? So if you are a very well-intentioned safety professional, you'd be looking probably not at the actual relay inside, but at the product specs, and you would say a 15 amp rated, right? This should work for my grinder. And so this is where it gets a little weird. We obviously know that these were failing already at a huge rate. And so we have to understand a little bit about electrically what's happening. So does anyone remember doing that experiment in when you were younger with the nail and the battery, like on the right there, make a little electromagnet? So motors are basically just big electromagnets, right? They're what's called an inductive load. Induction being a way that you can kind of store energy in a magnetic field. Now, anyone also remember when you were making this little thing when you were in 5th grade, what happened when you connected and disconnected it? You may remember there's tiny little sparks. And that is stored energy being stored in a magnetic field trying to discharge itself. And so when you're switching motors, specifically motors, they are a notoriously difficult load to switch, because any actual switch, right, just like shown on the left here, is 2 pieces of metal that touch each other, right? That's what most switches are when you get back to their most basic point. But a motor, every time you disconnect it, does this. So you see that welding arc flash? A reasonably loaded motor will do that every time you disconnect it. And so you can imagine that that would be a very destructive thing for switches. And so you have to have switching devices or relays that are made for motor use. And this is why this thing fails, because that tiny little relay, that's not rated for motors. And we're gonna kind of pause here and be like, wait. I thought this thing was approved by UL. It is, but it's approved as a quote unquote appliance control. And so if you look at the actual UL standard that this thing is approved under, UL 246A, it covers things like household appliances, lights, audio video equipment, not intended for controlling motor operated appliances. So this is not only not meant for industrial, it's not even meant for your blender. Yet their marketing material is right next to big pictures of table saws and drill presses and mills, and it would be very easy for someone to fall into that trap. Versus, for example, UL 508, which is one of the industrial control equipment standards, which historically, it's changing a little bit now, it's specifically designed for the control of motors in an industrial environment. So just as a quick comparison, these 2 relays shown here are to scale and have kind of similar ratings, right? So those would both be good for up to a 15 amp motor. The one on the left is obviously tiny and not made to handle those arcs and sparks we showed, where the one on the right is, and it can handle that because it's been tested to a much, much higher standard. So again, it's one of those things where like you wouldn't know unless you were crazy like me and dig through standards all day. And so the way though, the kind of lesson from this is when you're looking for things, when you're shopping for products, whether it's an industrial motor control or a emergency stop switch, to really look to see, is it recognized by a test lab or is it listed by a test lab? And is it listed for that purpose? So that's a big, big distinction, right? So is it listed for that purpose? Now, Doug mentions that this G7L relay has a lot of features built into it as part of that motor requirement, which makes it able to extinguish those arcs. And part of it is that it actually has double contact. So instead of like one piece of metal separating, there's 2, so it shares the load. Also has different ways that arc can travel that make it like basically go away from the contacts faster. Lots of things and that are built into this, not too different from a circuit breaker, that make it safer for motors. And the way to know that I, apparently don't have that slide up here, is that it'll actually say HP, horsepower rating on it, right? It'll say, this is rated for a 1 horsepower load. So